Alright, good afternoon everyone. Our focus for this lesson is Pythagorean Theory, as was requested. The Pythagoras Theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now that is very important. You have to understand what the Pythagoras theory is. Alright? Now, the Pythagoras theory is associated with a very special type of triangle, which is the right angle triangle. And on the board, I have a representation of the right angle triangle. And some properties of the right angle triangle. The right angle triangle always have one right angle. And it always uses a little square box to represent that right angle there. Now opposite, and let me draw an arrow to show that, opposite from the right angle is always the longest side, and that side is named the hypotenuse. So the hypotenuse is the longest side of the right angle triangle. Now the other two angle is an acute angle, which is this angle here, and this angle here is an acute angle, and they sum to give 90 degrees. And you know from previous lessons that angles that sum to give 90 degrees, we refer to them as complementary angle. Now we are going to investigate the relationship of the right angle triangle with the lengths. So let's say on this triangle, I know the height of this triangle, and the height is said to be 3 meters. And let's say here, which is the base, is 4 meters. And let's say the longest side, which is the hypotenuse, is 5 meters. Now we are going to see if we can study the length of this right angle triangle to see if there is any relationships among the length of the sides. Alright? Now, if you note, let's say if we add 3 plus 4, if we add 3 plus 4, that is equal to 7. That's not interesting. If we have 5 minus 3, that is equal to 2, which is not interesting. If we have 5 minus 4 is equal to 1, and that's not interesting. Now, let's say that you were asked to draw a square on each side of this triangle here, and they ask you to calculate the area of each square. So if we draw a square on this side here, and note that my diagram is not drawn to scale. If we draw a square here and we complete the square on each side, and you're asked to calculate the area of each square, let's see what will happen. And you will have a square going in this direction here. I'm running out of space here, but let's just visualize it. Now let's say that we have a square on each side. You know that the square have lengths of 3 centimeters, so all around is 3 centimeters. And you were asked to find the area of each of the square. Now, if we find the area of this square, our answer would be 9 meters squared. And if we find the area of this square, our answer would be 16 meters squared. And here, our answer would be 25 meters squared. let's see if we can study the area of these length and see if there's any relationship among them. Now, if we have 9 plus 16, we know that that would equal to 25, which is the area of the hypotenuse. That's interesting. Note too, if we have 25 minus 16, that will give us 9, and that's very interesting. And also, if we have 25 minus 9, that is equal to 16. Wow, this is beautiful. So now we realize that the area, if we have a triangle and we created an area and a square on each side and calculate the area, then we will notice that we started to have some relationships among the lengths of the side. Clearly here, you can note that 9 plus 16 will give you the area of the hypotenuse here, which is a very interesting relationship among the numbers. And also, if we have 25 and we subtract this side area from it, we get this area over here. So we can clearly see that. Let's see where that can put us. Now, let's just investigate these numbers some more and see if we can come up with some more interesting thing about the right angle. Note here, we note here, if you should root 9, then that would give you 3. And that seems to give you the length of one side of the square. And if you root 25, that would give us 5. That's very interesting as well. And if you root 16, that would give us 4. So we are starting to see a pattern among these numbers now. If we multiply them together, we get 9, 16, and 25 for each side. And then if we add the two shortest side, we realize that it gives us the area of the longest side, which is very interesting. Also, if we have the longest side area and we take one of the shortest side area from it, it gives us the other. That's really interesting as well. And if we square root each area, we get back the length of one side of the square. And all of those are really, really interesting. So this is basically what the Pythagoras theorem is saying. It is saying that in a right angle triangle, the square, or the area of each side, when you created a square and then the square of the hypotenuse is equal to the sum of the square of the other two sides. And you can see that because the two shortest side here is one side with 3, one side with 4. When we square them, we get 9 and 16. And when we add them together, it gives us the area of the hypotenuse, because 5 is associated with the hypotenuse, right? Which is very, very, very interesting. Now, you would have always taught a formula, right? So let's say at this vertex we have a letter, which is C. And here we have A, and at this vertex we have B. Now normally, how you name the side of a triangle, you give the opposite side to the vertex the letter that the vertex have, but you use a common letter. So for example, in this case, at this vertex we have capital B. So where 3 would be, that would be the side common B. Where 5 would be opposite from C, that would be common C. and opposite from this vertex is this side where 4 is, and this would be common A. Now we can apply the same relationship to variables. Here clearly we can see that C would be the hypotenuse and we're squaring. So C squared is equal to A squared plus B squared. And that's how we came up with, our mathematician came up with the formula for the Pythagoras Theorem. Now, after studying several right angle triangles, he discovered that there's a relationship when you find the area of each side, and that if you know two sides and you know the area, you can always find an unknown side and the right angle triangles. And these numbers over here clearly states that, because you notice 9 plus 16 give us 25, 25 minus 16 give us 9, 25 minus 9 give us 16. Root 9 is equal to 3, root 25 is equal to 5, root 16 is equal to 4. And you need all of these skills. Alright? So that's basically, this is basically a representation of the Pythagoras Theorem, where in this case, where you have C squared would be the hypotenuse. You can use whichever letter you want, but I just want you to understand the concept behind the Pythagoras Theorem. So if somebody asks you what is the Pythagoras Theorem, please do not say that it is C squared equal A squared plus B squared. That's not the Pythagoras Theorem. That is just a representation of the Pythagoras Theorem. The Pythagoras Theorem is the square of the hypotenuse is equal to the sum of the square of the other two sides. That is key there. And all students who is doing this topic needs to understand that concept. Alright? Now that we know what the Pythagorean theory will look like using strictly letters, we can further go to investigate each of these letters to see if we can transpose it and see whatever relationship we can get out of it. Now we know that in this form that I have it here, C squared would represent where the hypotenuse is, right? That means if I want to calculate the length of the hypotenuse, which is C and not C squared, all you need to do is to say that you just need to root both sides, and if you root both sides, you can say C squared is equal to A squared plus B squared. If you root both sides here and you root this side, you realize that this square root sign cancels out this 2, so C would actually equal to the square root of A squared plus B squared. And that's one way you can write it, right? Now from this formula here, we can manipulate it to make each of these letters the subject of the formula. So we are saying that if you know what this formula here is saying, which is C squared equal A squared plus B squared, this is saying that if you know the length of the two shortest sides, then you can use this formula to calculate the length of the hypotenuse. That's what this is saying. And this is how you do it. Now, what if we know the length of the hypotenuse and we know the length of one of the shortest side and we want to calculate the other one? Then you can manipulate it to make each of these the subject of the formula. And this is how you do it. We know that C squared is equal to A squared plus b squared. Right? Now I'm going to try and see if I can make a squared the subject of the formula. Now if I want to make a squared the subject of the formula, I need to subtract b squared from both sides. So if I subtract b squared from this side, I am left back with only a squared. And over here, I'm left back with c squared minus b squared. So that's it. So if I want to know the value of a, which would be where 4 is in this case, then I can manipulate the formula to make a the subject of the formula. But remember, they don't ask me for a squared. They ask me for a. So we can go ahead and root both sides. So if I root both sides, I left back with a being equal to the square root of c squared minus b squared. That's it there. And you can do the same thing for b squared. We can write it back here and say c squared is equal to b squared plus a squared. And it doesn't matter now. Addition doesn't matter. If you say 2 plus 3, this is still equal to 3 plus 2. Doesn't change the value. This is still 5. And this is still 5. So don't worry if I'm saying a squared plus b squared up there, and here I'm saying b squared plus a squared. It is the same thing. Alright? Now you want to manipulate this to make b squared the subject of the formula. So all you need to do is to subtract a squared from both sides. And you will see that c squared minus a squared is equal to b squared. Because if you subtract a squared from this side, you're just left back with b squared. Now you want to find b. You can go further to root both sides, and if you square root both sides, which is to square root this and square root all of this, then you get b equal to the square root of c squared minus a squared. Now remember that c squared represents the hypotenuse in this case based on the formula we are using. So c squared will represent the hypotenuse, right? So that's how you would manipulate the formula to find what you want. But note, if when you want to calculate the hypotenuse, you add. Note that you always add. You add the square of the other two sides. But if you are given the hypotenuse and one length of the other side, and you are asked to calculate any of the other two sides, you are always going to subtract. And I hope that you are paying key attention to that. Right? Now, let's try to see if we can make more sense of all of this that I have just done. We're going to look at a question. Alright? Because I know that maybe all of these explanations might not make much of a sense to you now, but an example will help to understand what I am saying. Alright? So now you would have understand and learn the Pythagorean theory. And we know that the Pythagorean theory states that the hypotenuse square, which is, we could call it h for hypotenuse, the hypotenuse square is equal to the square of the other two sides. And let's say the square of the other two sides is a squared plus b squared. Same, it is the same thing. I could just write above to show that this is c squared is equal to a squared plus b squared. You can use whatever letter you want. You just need to understand that it is the square of the hypotenuse that is equal to the sum of the square of the other two sides. Right? That is key. That is the key information there. So let's look at this example. It says, find the length of AB of the hypotenuse in the right angle triangle ABC. So here on the board we have a triangle, and this triangle is named ABC. Now, this is our 90 degree. The box indicates that this is a right angle triangle. The first thing that we need to do before we even think about solving for AB, we need to know which side is actually our hypotenuse. Now we know opposite, the hypotenuse is the longest side on the triangle. And also opposite from the right angle. That side that is opposite from the right angle is the hypotenuse. So right away, we know that this is the hypotenuse. Alright? And we use HYP for short for hypotenuse. So this is our hypotenuse. What do we know about the Pythagorean theorem? We know that the hypotenuse squared is equal to the square of this side plus the square of this side. That's what we know. That's what these formulas over here are saying. The hypotenuse. And I mean, here I specifically use H for you to understand that it is the hypotenuse I am talking about. Now, if we're going to apply the Pythagorean theory to this question, here we can use the endpoint of the lines to represent which side these are. Or you can use the scale that I just said, that opposite from the vertex. So this here, you could say that opposite from this vertex here, this would be A. Opposite from C here, this would be little c. And opposite from this vertex would be little b, which is common b. Right? Alright, so since we have A, B, and C, let us work with the one with A, B, and C so I don't confuse you. So what we know that C squared is equal to A squared plus B squared. Now we have identified where C is, where B is, where A is. We can see from the diagram that A is equal to 5 centimeter, and we can see that B is equal to 12 centimeter, and we can clearly see that C is what we want to find. That's a question mark there. So we would have write our formula already. So all you need to do is to substitute the values that you have been given from the triangle in the formula. So we know that A would write back C squared is equal to A squared, which is 5 here, so this would be 5 squared, plus 12 squared, which is B, which is 12 squared. Now, you'd have note that whenever you square a number, the index tells you how many times to multiply the base. So 5 squared means 5 multiplied by 5. And 12 squares mean 12 multiplied by 12. That's what it means. So let's continue solving for C. So C squared is equal to 5 squared, which is 5 times 5. And 5 times 5 gives us 25. Here. Plus 12 squared, and 12 squared means 12 times 12, and 12 times 12 is 144. Alright? Now that you know, I can just simply erase this, so I have more space. So C squared is equal to 25 plus 144. 25 plus 144 is equal to 169. Now, the question is, are you finished? No. They did not ask us to calculate C squared. They asked us to calculate the value of AB, and in this case we are saying AB is the same thing as C here. Alright? And you could always write a statement to say, let AB equal C. So you know that's exactly what you're solving for. So here we need to square root both sides because we don't need the square. So write back what we have, which is C squared is equal to 169. Then you take the square root of this side and you take the square root of this side. Now this square root sign is going to cancel out the square sign, so you're left back with c here. And c is equal to the square root of 169. And when you square root 169, the answer is 13. Because 13 times 13 equals 169. That means the square root of 169 is 13. But remember your unit. It gives us a unit which is centimeter, so it is 13 centimeter. So you say, therefore, AB is equal to 13 centimeter. And that's how you apply the Pythagoras theorem. Right? So this side would actually be, 13 centimeter. Right? Now, what if you know this side now? You know that this is 13. And let's say that you didn't know that this was 12. Right? Let me just rub off this now, because we are just going to play around with this triangle. So I don't want anybody to get confused. We would have solved this part of the question. So we are now going to play around with this triangle and the lengths, and to see what is going to happen with them, to see if we can understand the concept and how to apply the Pythagoras theorem correctly. So we know that the hypotenuse is 13 centimeter, but we don't know, let's say that we don't know what AC is. And in this case, AC is the same thing as B. So we don't know what this is, and we want to find what B is. Right? They want us to find what B is. So we are going to say, let AC equal B. Right? And let me just write it out. We are solving for the length, solving for the length B now, right? So we're solving for the length. We're solving for the length, which is AC. So that's what we want to find, right? So we want to find the value of AC. Let's say we didn't know. Now, we know the Pythagoras theorem. We know that this is a right angle triangle. We know that this side is the hypotenuse. We have the value of the hypotenuse. We have a value of the other side, or one of the shorter side. And we want to find the value of one of the other short side. Now, again, you write out the theory. What does the theory state? The theory says the hypotenuse square in this case, which is common C, is C squared is equal to A squared plus B squared. That's basically it. That's a representation of it. And this is saying if we know the hypotenuse, then the square of the other two sides is equal to it. Now, we know the hypotenuse in this case. Now, you could manipulate the formula to make B the subject of the formula, since B is what we want to find, to make it easier, and it just takes us in one step. So you could manipulate this to make B the subject of the formula. What you're going to do, you're going to subtract A from both sides. So you're going to say that C squared minus A squared is equal to A squared plus B squared minus A squared. Now clearly, here, A squared minus A squared give us 0. So all we're left back with is B squared. And we're left back with on this side, which is C squared minus A squared. Clear there? So, but what do we want to find? We want to find B. But this is B squared. But we can go further to manipulate this and get B by itself. So if we root this side, which is the square root, and we square root this side, we also know that this would equal to b here, because this square root cancels out the 2. And all we left back with here is the square root of c squared minus a squared. Cool? Because that's what we want to find, which is b. Right? Now that you have the formula here, all you need to do is to just sub this value in it. So we can therefore say that b, and I'm going to write the b on this side, so b is equal to the square root of c squared. What is c squared in this case? 13. So this is 13 squared minus a squared. What is a here? A is 5, so this is 5 squared. Now b is equal to the square root. 13 squared is 169 minus 5 squared is 25. Clear there? Now you need to solve what's underneath the square root sign before you root. So here we would have noted that, let's bring it over here, b is equal to the square root. If we have 169 minus 25, that gives us 144. So when you square root 144, b is equal to 12. And remember the unit, which is centimeter. But we did know that b was already 12 centimeter. But I just wanted to show you how you would solve it if you didn't know. Alright? So b here is 12 centimeter. Alright, let's play with this diagram some more. Let's say that we didn't know this side. We didn't know that this was 5. And all they put there was a. And they said that calculate the value of a. Right? Now, let me just erase this side so that we can have enough space to solve this. I hope that I am making sense to all of you. Alright, so now we're saying that we don't know this value. We're assuming as if we don't know what a is, and we want to calculate a. Again, it says that we can use a representation to say that c squared is equal to a squared plus b squared, where c squared is the hypotenuse. So c squared is the hypotenuse, right? And there's no one approach to this. If you notice, I am keep changing the approach because I want you to get comfortable using more than one